Good.
So we have time for several questions.
So for your population simulations, they seem pretty accessible. So, they could be used for nefarious purposes. What are your plans for security on those? Especially if people are able to develop their own apps to access the information.
Is this on, or do I need to switch it? Yes. So 15 years ago, someone tried to stop our epidemic simulation modeling because of exactly that. But if you think about it for a while, I think you can convince yourself that the benefits to understanding how to mitigate and control, say, a disease outbreak far outweigh the pretty small likelihood that somebody could use this as a terrorist planning tool. Sometimes it's not quite so clear-cut. For example, we're working on a paper right now that looks at targeted damage to the electrical power infrastructure and where there might be vulnerabilities in that. Those tools aren't they're more useful for us than they would be for someone trying to develop an attack, because we know that this is it's a synthetic data information environment. If you planned an attack based on this, you'd be optimizing your attack in this virtual world that does not specifically mirror the real world. Whereas we can draw rules of thumb and lessons learned from those kinds of simulations that do apply in general to the real world.
So that kind of brings up my second question, and that is, how do you actually test your simulations to determine their accuracy in real world?
Wow, Stephen. we actually forecasted this question would come up, so. Chris calls it a general's question, who can, be at the back, not pay attention, and then ask this very hard question that's very hard to answer. But I'll take a shot and maybe let others also take a shot. So I think the ability to understand these systems in terms of making sure that you have validated it, if that's the word you want to use, is much more complicated, but is doable. So the first thing to understand is that predictive validity is not the way we want to understand these systems. Physical systems certainly have been ones where people have worked with predictive validity. So if you can reproduce a phenomena in exactly that form, then the system is viewed to be validated. It's only one part of the story here. We have tried to actually build a program in which we have a fairly strong mathematical program to understand the structural properties of the systems. We try to understand how the system is put together so that we have faith in it. We have certainly tried to do the predictive validity as well, but that turns out to be relatively easy to do. In fact, as you might have guessed, almost every paper we write on epidemic simulations, they want us to try and reproduce the old results. And it's actually fairly easy to reproduce a flu in 1918 if you so choose, but has very little to do with what's really likely to happen. So I think that's an exercise that you need to do to satisfy a reviewer, but actually does not have much of information content in terms of understanding. So there's a lot of functional validation that goes on, structural validation that goes on, and I think a particular class of validation techniques that maybe not as technique as such, but an idea is putting this out in the field for users to use it. And when policymakers use this and make decisions over and over again with a tool like this, we have much more confidence in its utility at the end of the day, rather than just exercise with pen and pencil. So that's at least my answer, and maybe others.
I'll just add to that. So when we construct a synthetic information system, it's a multi-stage process. And what we end up with is a complex data structure, right? And so you can't validate it just by trying to reproduce one sequence of numbers, because there are too many parameters that you could tune. So really what we have to do is we have to validate it at every stage of the process in as many ways as we can, right? So when we just generate the demographics of the population, we have to validate that. when we add the activities, we have to validate that. When we add the activity locations, we have to validate that. And so we've developed techniques for validating at each step of the process that what we're looking at is something sensible. So I can point you to papers about that.
Is there some method of feedback, like especially with the policymakers, to determine how effectively their policies work based on those simulations?
Yeah, so that's a great question. So, so one thing I want to point out is that at some point, you have to make a forecast about something that hasn't happened yet, right? So like we're looking at this scenario called the National Planning Scenario 1, which is an improvised nuclear device going off in Washington, D.C., right? It is something that they want to plan for. It has never happened anywhere in the US. So how do you validate it? And the answer is you can't. You just sort of have to make a prediction. You have to sort of, stake a claim at some point. And what you do is you say that here's everything that I'm using to make the prediction. Here's my whole model. It's public, and everything is validated within it. But since the event has never happened, you can't talk about validating that. That is my prediction, right? And in fact, if you think about it, every time a flu season comes around, it's different. It's a different strain of the flu. It may come about start in a different place in the country and so forth, right? So you want to be able to say ahead of time, this is what's going to happen, and validation only happens if that event actually happens, and you can compare your data with predictions.
I'm going to keep talking because I think this is an important question. Another way to think about what we're doing is to make it plain to the user what the consequences of their hypotheses are and their assumptions about the system. In a complex system of many interacting parts, it's not always obvious if you say, well, I think this is what's driving something. If you put a driving mechanism in, you don't know what's going to happen. So in part, what we're doing is providing a way just to see what the consequences of the hypothesis people have are. So in that sense, as long as we can guarantee that this hypothesis would in fact lead to those consequences, then it's really a tool that lets people do traditional sort of hypothesis validation experiments. It's like we're not saying this is what's going to happen. We're saying if you think that's what the situation is now and this is what's driving it, then this is what's going to happen, because that's the piece you can get to with a causal model.
So you can view this as a counterfactual in silico laboratory, right? You can basically play out what-if scenarios with this. Rather than just talking about forecasting specific events, you're really trying to support the policymakers' efforts in trying to understand what would happen if they take certain actions. And so far as these the specific decisions they take them in the right direction, in our opinion, that's actually a form of validation that's very powerful in that particular setting.
Sorry, I just wanted to add one thing about the Ebola response in particular. So in the beginning, there were these very dire forecasts that said that millions of people were going to get sick and die, and it didn't turn out to be as dire as the forecasts. That doesn't necessarily mean that those forecasts were wrong, because one of the reasons that it wasn't that dire is because people changed their behavior. And one of the reasons that they changed the behavior was because of these forecasts. So unlike physical systems, this is a case where just making the forecasts actually feeds back into the system and changes the system itself.
Anyone else before we go on? Well, actually, I'll say something about that, and then I'll ask my question. That the one thing that I think is really powerful about what you're doing is the transparency of how the assumptions and the behaviors are realized in the model, that it's not one of these big black boxes that you can't really see what's happening. So I'll just add that from some of my experience with these. But now my question. So I think it's great we're going to have the global population, in a year, but you guys also talked about, using this technology for modeling, beneath the skin and above the skin. So what's our time horizon of connecting this, of actually being able to move from below the skin to above the skin and out to the world?
I think we're already starting to do that with Joseph, where we started to connect, building out models for things below the skin. We hope that we'll be able to connect it at a population-wide analysis, in an appropriate way. And maybe a very coarse answer is when we get the funding to do it, that we'll do this. Because at the end of the day, that's what will determine when we do this.
Where are the sponsors when
So
you need them?
we are ready for it.
Thank you.
I'm wondering about the major bottleneck for the predictive power of your models. So is it actually, do you really see still shortcomings in the models themselves, in the way how you build them, or is it more like the data that you can actually get into the models, or is it human behavior that's not perfectly understood and will suddenly go in odd ways that maybe are not incorporated? So where do you see the major problems in having the best models?
All of the above. So the important thing to understand is that it's not like in 1 year we'll be done. It's not like we're going to have the global synthetic population in 1 year and that's it, and it's all applications from there on, right? Because we're always in a state of refining models, including models about human behavior, understanding about how policy impacts human behavior and human interactions and so forth. So there isn't one particular bottleneck that's going to hold us back. Really, everything has to be sort of constantly updated. For one thing, the population changes over time, right?
Right. To make, at least to give a positive side of the story, so we are working with another group at Virginia Tech. Naren leads the project with IARPA, and we've been very successful in forecasting various social and health events. We've taken lots of data, open data, commercial data, data that was hard to get, and use these models along with statistical models to do actually I would say the best, because there was a competition as it goes with any of these DoD style projects, and we won the competition. So our forecasts are actually fairly good from any meaningful comparative standards.
Great. Well, let's take this opportunity to thank NDSSL again for a really wonderful presentation and some nice, thorough answers.